In this video we are going to discuss regarding fluid system of the eye and intraocular fluid. Regarding intraocular fluid, it is a physiology video. So regarding this, we know this is a rough diagram for eye. So this is the optic nerve. This is a layer of retina, sclera, retina, and this is lens. This is lens, and then this is ciliary body, ciliary body. This is iris, cornea. So I am not going to explain regarding this part. So I am going to only explain regarding how our intraocular fluid, or there is a vitreous aqueous humor or vitreous humor, how maintain. So this first we discuss regarding the aqueous behind the lens. This is the behind the lens. In between lens and the retina, there is a fluid. In this region there is a fluid. This fluid is known as vitreous humor. This is vitreous humor, and also known as vitreous body. So regarding this is it is between the retina and the lens, and it is naturally look like gel. It is like gel and and it is not flowing freely as compared to the aqueous humor. So when we look at the composition, there is fine fibrillar network of elongated proteoglycans. Elongated proteoglycans, and that's trapped water. So there is little bit there is flowing of the water, or there is a freely moving of the some amount of the only fluids. So when we look at the function of this, is maintain the shape of the posterior eyeball. When we look at the function of this, it's it helps to maintain the shape of posterior eyeballs, and hold the retina in the place, hold retina in place, and each allow to the light transmission, and also allow to light transmission. So this is regarding the vitreous humor. Regarding the aqueous humor, so when you look at the aqueous humor, it is present in the anterior to the lens, and it is in between the cornea, in between the cornea. So this is known as aqueous humor. And this is like if there is a chamber, so iris is dividing is in the chamber, like this is the posterior chamber, chamber, and there is an anterior chamber. This is the anterior chamber. So when we look at the, it is naturally flow from the, like it is water flow, so it is flow, and it's synthesis, and it's also drainage. So we are discussed regarding this, and it's maintain the like intraocular pressure of the lens lens and the cornea, and also it supplies the nutrients, and also it's drain the metabolic waste from the customer. When we look at the function for easy understanding, supply nutrients, we discuss how this all function done. Maintain intraocular pressure, then drain metabolic wastes, drains metabolic wastes. When you look at the formation of this aqueous humor, so there is like it's made in the like ciliary process. This is known as ciliary process. This is ciliary process. Here is the ciliary process, and in the ciliary process there is like ciliary body, and this ciliary body is a folded epithelial structure behind the iris. There is a folded, this is a folded structure. So when we look in this image, like this is a ciliary process, and there is this ciliary body, ciliary, it is a like picture of the ciliary body. So in the ciliary body there is ciliary process. In the ciliary process, like it's like when you look, this is the ciliary process, and in between there is a vascular layer. This is a vascular layer. It is surrounded by the like vascular layer is surrounded by the ciliary body, and there is a ciliary process. It is a folding structure. So when we look at the surface area of this like there is a 6 cm square per eye. There is a surface area of this ciliary body, and when we look at the structure, it has highly secretive, like it has highly secretive, this epithelium, highly secretory epithelial cells, and like overlying the vascular, this is the vascular region. In vascular region there is like highly secretory epithelial cell and vascular stroma. So when we look at the mechanism of like how secretion occur, so there is like active transport of the in this image, like here we can look, there is an active transport of sodium ion. Due to this active transport, here is the ATP used, and due to this active secretion of the sodium ion for the maintaining the charge balance, there is also coming of the chloride and the bicarbonates in this posterior chamber. And there is also like some secretion of like glucose, amino from this amino acid, and there is like also ascorbic acid. And when it's come like electric chemically neutralized, there is a come to the like there is a chloride and the bicarbonate. So this chloride, bicarbonate and sodium, it's form the osmotic gradient, and there is a osmosis occur, and there is osmosis occur, and due to this osmosis there is water dragged or water comes through the vascular region. So when we look in this image, due to this there is a like sodium due to the ATP, and there is chloride, bicarbonate, due to electrical gradient, electrical neutralization, and when you look, there is like osmosis. This make osmosis of water, water. So there is like and this fluid come. So when the fluid come and it's move, like from posterior there is a coming out, and it's come and passes through this. There is a like pupil, and between there is like slightly less amount of the space to the pass through the posterior to the anterior, and it's coming in the anterior compartment or anterior chamber. So when we look, there is a like posterior chamber to the behind the iris, and this coming to the pupil to the anterior chamber, and then there is a drainage. So now it has drainage. So in this region there is a like idiocorneal angles from the cornea and the iris. There is a angle between these. This is known as iridocorneal angle. So this angle is known as, like we can write here in between this there is a angle. So this angle is known as iridocorneal angle, and in this angle there is a drainage system occur. There is a drainage, so drains. So when you look at, there is a like a structure in the outflow. There is a trabecular. Then it is like trabecular is like a porous tissue. It is a porous tissue that filters the humors, and there is a canal of Escalem. This is the canal of Escalem, and in this canal of Escalem there is the escleral venous sinus. This is escleral venous sinus, and in this sinus there is a like circulatory vein around eye. Like when you look, there is a like circulatory vein. These are the circulatory vein, and this circulatory vein is aqueous vein, and then it's blood veins, and then it inside the sclera, and it is present in the sclera. So the porous, that is even the protein RBC sized particle can be passes through this trabeculi, and in the trabeculi there is a passage of like protein and RBC sized particles, only particles only from this sclem, and it's the fluid passes inside the aqueous venous. This is the aqueous venous. From this is passed into aqueous venous. From the aqueous vein, it passes in the episcleral veins. There is the episcleral. So that there is a episcleral veins, and through this episcleral it's coming to the general circulation. This is the like how drainage system occur, and there is like it contains like aqueous humors only, so not blood. The aqueous vascular structure seen. Now moving on, the like there is like formation versus drainage sum. Like how there is a formation. Like when you look at the formation rate, so production rate is like 2 to 3 microliter per minute, and it is like maintain the intraocular pressure maintained by the equilibrium. So formation equilibrium between the formation and drainage. So if the drainage is blocked, so there is increased formation. So if we block, there is a formation is constant, but there is an increased intraocular pressure, intraocular pressure, and that lead to the like glaucoma risk. We discuss more regarding when you discuss the pathology of the glaucoma. This is a like formation, and how there is a like clinical correlation we are relating. So when you look, this is the function of, when you look the important function of this, uh, why we need to these fluids. So for important function, there is like maintaining intraocular pressure, so that keep the eyeball properly inflamed, and we need to like provide nutrients and the removal of the waste, especially avascular structure like lens and the cornea. Cornea is avascular and lens as well, so we need to the like supply to the nutrients, and there is the waste, so we need to the drainage of the drainage of the some waste from the lens and the cornea, metabolic waste. So we need to this type of circulation, aqueous humor circulation. And it's like also preserve the optical clarity, like it's clear, like here is the lens, and when it is passed through this, like this way and from this way, so it's help to the like clean the lens, clean the this surface of the lens, clean. These are the some function why we need it. And there is also support the retinal position and the function, like it also support the retinal function and so function and their positioning. So this is all regarding the fluid system of the eye and intraocular pressure, which are given in the like our guidance hall. So I think it's helpful.